Welcome back to JVM Internals Crashcasts. I'm your host, Sheila, and today we're diving deeper into the fascinating world of class loading. We're currently in Level 2 of our series, focusing on operational understanding of the JVM. In our previous episode, we explored the class loader hierarchy, and now we're moving on to custom class loaders. Joining me as always is our JVM expert, Victor. Hey, Victor. Are you ready to unravel the mysteries of custom class loaders?
Hey Sheila. Absolutely, I'm excited to explore this topic with you and our listeners. Custom class loaders are a powerful feature of the JVM that allows developers to extend and customize the class loading process. This can open up some really interesting possibilities.
Before we dive in, let's start with a quiz question for our listeners. Here's a tricky one. In what scenario might you use a custom class loader to load classes from a database instead of from the file system? Think about it, and we'll reveal the answer at the end of the episode.
That's an intriguing question, Sheila. It definitely makes you think about the flexibility of class loading in Java. I'm curious to see how many of our listeners can come up with a practical use case for this. It's not something you'd encounter every day, but understanding when and why you might need this can really expand your perspective on JVM internals.
Agreed, Victor. Now, let's start with the basics. Can you explain what exactly a custom class loader is?
Certainly. A custom class loader is a Java class that extends the abstract class loader class. It allows developers to define their own way of loading classes into the JVM, beyond the default mechanisms provided by the system class loader and application class loader.
That's interesting. So, it's like we're creating our own specialized librarian for our Java books, right? Can you give us some examples of when we might need a custom class loader?
That's a great analogy, Sheila. And yes, there are several scenarios where custom class loaders come in handy. For instance, you might use them to 1. Load classes from non-standard locations, like a network or a database. 2. Modify bytecode on the fly before it's loaded into the JVM. 3. Implement a plugin system where you can load and unload classes dynamically. And 4. Create a separate namespace for loaded classes to avoid conflicts.
Those are some powerful use cases. How would one go about creating a custom class loader?
Creating a custom class loader involves extending the class loader class and overriding its findClass method. In this method, you'd implement your own logic to load the class bytes from wherever you're storing them. Then, you'd use these bytes to define the class in the JVM. It's like telling the JVM, here's the blueprint for this class, now make it available for use.
That seems straightforward enough. But I've heard that there's something called the delegation model that we need to be aware of when working with custom class loaders. Can you elaborate on that?
Absolutely, Sheila. The delegation model is a fundamental concept in the JVM's class loading mechanism. When a class loader is asked to load a class, it first delegates the request to its parent class loader. This continues up the hierarchy until it reaches the bootstrap class loader. Only if the parent can't find the class does the current class loader attempt to load it itself.
That's interesting. So, does that mean our custom class loader might not always be used, even if we've implemented it?
Exactly. By default, your custom class loader will still follow this delegation model. However, you can override this behavior by overriding the load class method instead of find class. But be cautious. Breaking the delegation model can lead to security issues and class loading inconsistencies.
Speaking of security, are there any specific security considerations we should be aware of when using custom class loaders?
Great question, Sheila. Security is indeed a crucial aspect when working with custom class loaders. The JVM relies on the class loading process for enforcing security policies. When you implement a custom class loader, you're taking on the responsibility of maintaining these security guarantees. Some key points to consider are: 1. Ensure that your custom class loader doesn't load malicious code. 2. Be careful about breaking the delegation model, as it can bypass security checks. 3. If you're loading classes from remote sources, implement proper authentication and verification mechanisms. And 4. Be aware that custom class loaders can potentially be used to bypass Java's access control mechanisms if not implemented carefully.
Those are important points to keep in mind. Now, could you share some best practices for working with custom class loaders?
Certainly. Here are some best practices. 1. Follow the principle of least privilege. Only give your custom class loader the minimum permissions it needs. 2. Stick to the delegation model unless you have a very good reason not to. 3. Implement proper error handling and logging in your custom class loader. 4. Be mindful of memory usage. Loaded classes stay in memory until the class loader is garbage collected. And 5. Consider using URL class loader for simple cases where you just need to load classes from non-standard locations. And a common pitfall to avoid: be careful with static variables when using multiple class loaders, as each loader can create its own copy of the class, leading to unexpected behavior.
Those are valuable tips, Victor. Before we wrap up, do you have any interesting facts about custom class loaders you'd like to share?
Sure, here's an interesting tidbit. Some JVM languages like Groovy use custom class loaders extensively to implement their dynamic features. Groovy's Groovy class loader, for instance, can compile and load Groovy scripts on the fly.
That's fascinating. It really shows how powerful custom class loaders can be. Now, let's reveal the answer to our quiz question. Victor, would you like to do the honors?
Of course. The scenario where you might use a custom class loader to load classes from a database could be in a plugin system for a large distributed application. Imagine you have a system where different nodes need to run different versions of certain modules. By storing the bytecode in a central database and using a custom class loader, you could ensure that each node loads the correct version of each class, allowing for fine-grained control over the deployed code across your distributed system.
That's a great example, Victor. To summarize today's episode: 1. Custom class loaders allow developers to define their own class loading mechanisms. 2. They're useful for loading classes from non-standard locations, modifying bytecode on the fly, implementing plugin systems, and creating separate namespaces. 3. Creating a custom class loader involves extending class loader and overriding find class or load class. 4. The delegation model is a crucial concept to understand and respect. 5. Security considerations are paramount when implementing custom class loaders. And 6. Best practices include following the principle of least privilege and sticking to the delegation model when possible. In our next episode, we'll be exploring the structure of class files, which will give us a deeper understanding of what our class loaders are actually loading. Don't miss it.
That's a great summary, Sheila. I'm looking forward to our deep dive into class file structure.
Thanks, Victor. And to our listeners, if you've enjoyed this episode, please subscribe to JVM Internals Crashcasts and leave us a rating. Your support helps us continue producing this content. Until next time, happy coding.